The numbers in order of each row and the numbers in order of each column of a 5 into 5 array of integers form an arithmetic progression of length 5. The numbers in positions 5, 5, 2, 4, 4, 3 and 3, 1 are 0, 48, 16 and 12 respectively. What number is in position 1, 2? This is a multiple choice question with choices. A is 7, B is 21, C is 36 and D no number. We have shown the 5 into 5 array here. There are 5 dashes in the first row, 5 dashes in the second row, similarly 5 dashes in the third row, fourth row and fifth row. There are 5 columns, 1, 2, 3, 4 and 5. So this is a 5 by 5 array. The data given is this. 48 is the number at the second row and fourth column. 12 is the number at third row and first column. 16 is the number at fourth row and third column. Similarly, 0 is there at fifth row and fifth column. Okay. It is also given that the 5 rows and 5 columns, they constitute arithmetic progressions. If we assume D as the common element of the arithmetic progression and A as the first element in the first row, then along the first row, the arithmetic progression would go like this: A plus D, A plus 2D, A plus 3D and A plus 4D. And in the second row, it will go as A plus D, A plus 2D, A plus 3D, A plus 4D, A plus 5D. In the first column, it will go as A plus D, A plus 2D, A plus 3D and A plus 4D. In the second column, it will go as A plus D, A plus 2D, A plus 3D, A plus 4D and A plus 5D. Similarly, for other rows and other columns, and we will get the last column as A plus 4D, A plus 5D, A plus 6D, A plus 7D and A plus 8D. Now, corresponding to the arrow on the left hand side and the arrow on the right hand side, we notice that A plus 4D is given to be 48, A plus 2D is given to be 12, A plus 5D is given to be 16 and A plus 8D is given to be 0. Let us call these as equation 1, 2, 3, 4. Now these are 4 simultaneous equations for only 2 variables. that are A and D. This is okay if the equations are consistent with each other. From equations 1 and 2, we get 2D is equal to 36 and therefore D is equal to 18. Now substituting this value of D in the second equation, we get A is equal to 12 minus 2D, that is equal to 12 minus 36 or minus 24. Therefore, A is equal to minus 24. We have to find the unknown number at position 1, 2, that is first row and second column, that is this position. That is first row and second column is A plus D. Therefore, since A is equal to minus 24 and D is equal to 18, A plus D is equal to minus 6. However, that will not be correct because of the following considerations. From equations 3 and 4, by subtraction, we get 3D is equal to minus 16. Therefore, D is equal to minus 16 by 3. Putting this value of D in one of the equations, we get A minus 8D is equal to minus 8 multiplied by minus 16 by 5, and that is equal to 128 by 5. Therefore, D is equal to minus 16 by 3 and A is equal to 128 by 5. These are two different sets of results for A and D. One set we have found here, one set we have found here. Obviously, the four equations given above are inconsistent. In writing out the values of different rows and columns of the array, we had implicitly assumed that the same arithmetic progression runs for both the rows as well as columns. This produced inconsistent results. Therefore, our assumption was wrong. Instead, let us take one AP, that is one arithmetic progression along the rows and another arithmetic progression along the columns. The question is ambiguous about this. So let us try out this variation. Before going any further, please like, subscribe, share and hit the bell so you can be immediately notified for new uploads. It is completely free and only takes a few seconds, and you can always unsubscribe later. Without further ado, let's proceed with the rest of the video. Let us assume a common difference of D along the rows and E along the columns. The resulting array is shown below with the known values in different positions shown. The given array is this, and we are going to show the new array in the next. Here in this diagram, we have assumed that the arithmetic array running along the rows has a common difference of D, and the arithmetic array running along the columns has a different common difference, that is E. Therefore, the array would be along the row A plus D, A plus 2D, a plus 3d, a plus 4d as before. However, the second row would be a plus e, a plus d plus e, a plus 2d plus e, a plus 3d plus e, a plus 4d plus e, so on and so forth. Finally, the fifth row would become a plus 4e, a plus d plus 4e, a plus 2d plus 4e, a plus 3d plus 4e, and a plus 4d plus 4e. In this depiction of the arrows, in this depiction of the arrays, we have shown the known positions in small boxes. That is, we know the number here, we know the number here, we know the number here, we know the number here. As we had done before, we will equate the symbolic depiction of the known positions and equate those with the known numbers given. One equation would be a plus 3d plus e will be 48. Another equation will be a plus 2e is equal to 12. Third equation will be a plus 2d plus 3e is equal to 16. And the last equation would be a plus 4d plus 4e is equal to 0. Let us call these four simultaneous equations as 5, 6, 7, and 8 respectively. Note that now we have three unknowns a, d, and e, and still there are four equations. Let us simultaneously solve for these unknowns and check whether these four equations are consistent or not. From equation 6, we get a is equal to 12 minus 2e. Substitute for a in equation 5 to get 12 minus 2e plus 3d plus e is equal to 48. Therefore, minus e plus 3d is equal to 36 and e is equal to 3d minus 36. Putting this in equation 7, we get a plus 2d plus 3e is equal to 16, or 12 minus 2e plus 2d plus 3e is equal to 16, or 12 plus e plus 2d is equal to 16, or 12 plus 3d minus 36 plus 2d is equal to 16, or 5d minus 24 is 16, or 5d is equal to 40. Therefore, d is equal to 8. Hence, e is equal to 3d minus 36, that is 24 minus 36, and that becomes e is equal to minus 12. So, we get a is equal to 12 minus 2e, that is equal to 12 plus 24, or a is equal to 36. So, the values we have got is a is equal to 36, d is equal to 8, and e is equal to minus 12 for the three variables. We have got the three values of the three unknown quantities d, e, and a by using only three equations 5, 6, and 7. To check for consistency, let us put these values of d, e, and a in the other remaining equation which we have not used so far. So, if you put These values in the equation 8, which is a plus 4d plus 4e is equal to 0, the left hand side becomes 36 plus 4 into 8 plus 4 multiplied by minus 12, that is equal to 36 plus 32 minus 48, that is equal to 20. But the right hand side has to be 0 for the set of equations to be consistent. And since here the left hand side is not equal to right hand side, equation 8 is not satisfied. Therefore, we come to the conclusion that the set of equations 5, 6, 7 and 8 are inconsistent. Therefore, our conclusion is the question does not yield any satisfactory answer. Therefore, choice D is correct. Choice D is no number. No number is correct.